Now in this NumPy, actually, we have a basic difference of the speed. NumPy is similar to list. NumPy is a consistent of array and it is similar to list, but it has a higher efficiency than list. This is because in NumPy we directly have the access to the data, whereas in list we have there is some processes we cannot manipulate directly the data. So over here it has a local reference, you can say, in NumPy, which helps us to give the data accessibility faster. Okay. Now NumPy is a library, so it should be written in some codes, right? So, but if you think that NumPy is totally written in Python, it is not correct. NumPy is a combination of Python and C++. The data handling part is done by C++, and the 50% or less than 50% part is done with Python. So it's a combination. This library actually is a combination of both Python and C++. Now, I mentioned you how to install it. If you have the Anaconda, you can do it by pip. If you don't have Anaconda and Spider, you need to do like this: pip install NumPy. This will help you install. And if you have it, then you don't require this. Will directly import it. So, importing NumPy. So this is how to import NumPy. Import NumPy, and this is done. Okay, this is done. We have imported NumPy, and now what we're gonna do? We're gonna do some examples of it, or we're gonna create some array. So there are many dimensions of array: 0 dimension, 1 dimension, 2 dimension, multi-dimension. So we're gonna discuss those dimensional arrays later on. But now what we're gonna do? We're gonna just create a array. So over here, to create an array, we will take a variable, okay, and we're gonna use this NumPy over here. This is a keyword over here, NumPy dot, and then array. We need to create an array, so we'll just write the array, and then we will just write the list, means the array numbers. So in a square bracket, we're gonna input the numbers 1, 2, 3, 4, and 5. Maybe 5 numbers are there. So this is the method of importing. You can see over here that first of all, what we took a parenthesis for this array function, and then inside that we have given a list, and inside the list we have given all the numbers. So this is how we are storing an array inside using NumPy. Now, if you want to print this, print array, then you're gonna find, if you want to save this, you're gonna, okay, sorry, python / session 3 day 3.py. Okay, so you're gonna see you are getting the list, you're getting the array. These are the numbers. So it is similar to the list, but the orientation or the handling of the data is much faster when it goes for a big numbers. You will see it in later on this, you will see it. Now I told you how to reduce this keyword, right? If you are feeling that it is a very big keyword, you want to shorten this keyword, you can easily shorten it. You can name it anything using the as keyword. Now this as, what it is doing, it is just reducing the importing the every element of this into this short notation, that is NP. And if you want to replace this NumPy using NP, then it is done. It will give you the same output. Let it get saved, and then we'll execute this. Okay, so it's giving the same output. So this is how we're going to store the NumPy as NP. Now this concept is totally new for you because we have completed list, and it is similar to list, but it is not list, it is an array. Okay, so now we'll just go, if you want to check the version of your NumPy, means I'm having Anaconda, so I'm having it my own version. So I can check it like print. Let me comment this. NumPy version check print, and we'll have like we're going to import it. So importing should be done. Let me uncomment this. And this is np, because we have stored in np dot a double underscore version, and then again double underscore. This is usually what we do. And let us save the code and execute this. So I'm using the version of 1.16.5. Okay. So if you're gonna use the Anaconda of latest version, then this version will change. If I'm gonna reinstall this pip install NumPy, then I will get the latest version of this. If I'm gonna install this, I will find the latest version of this. It will update all the values, previous versions, and provide me the latest version of it. So requirements already satisfied. NumPy, this is the latest version that I'm having into it. So it's telling all the requirements are satisfied, and we are done. If you have some previous versions, then if you follow this, it will upgrade the version. So this is how this utilizes. Now, if we move to next, then we will have something how to get the type of an array. Now, as we have done the type of list, type of dictionary, now we'll do type of array. So we'll just comment this. Type of array. Now, to know the type of array, we'll just create an array. So let this be the array. I'm just uncommenting this, and we'll just print type, and we'll pass on the array, means the variable, the NumPy variable. So we'll get the type. So let us see what is the type of it. So it's giving numpy.nd array. Now, what is this nd array? This array function is used to create the nd array. And in Python, in NumPy library, this nd array is the only responsible for creating arrays. Okay. So now if we move forward, then you will find that we will have to go to the dimensions on an array. Now, as I told you, dimensions are of many types: zero-dimensional array, one-dimensional array, two-dimensional array, three-dimensional array, many things. So we'll just continue with the dimensions of the array. So before that, let me know in the comment section that did you understood this? Till here, did you understood? Is the concept clear? What is NumPy? How NumPy is used, and how it is passed, and why it is passed than a list? Just let me know in the comment section. Okay, I hope it was clear to everyone. Now we'll move forward. And now we'll go with the zero-dimensional array. Now, what is a zero-dimensional array? Over here, you can see, if you go to the examples over here, like this, you will find that we are getting a single-dimensional array. Okay, do we need to write import NumPy every time we write any code? See, if you're writing it in this code, means day3.py, then once you need to write this import NumPy as np. That's it. Once you imported this NumPy inside this code, inside this file actually, then you will not require to import it again. But if you are going for day4.py, another file, then you need to import NumPy in that file also. Now, zero-dimensional array. Now, what is a zero-dimensional array? If you're just taking that array equals to np.array, and inside this we'll just find only a number, only a single number, then it is a zero-dimensional array. You can say there is no two axes, only one axis. Inside this, what you can see in this part, this is I axis, and this is J, row. There are rows and columns, so it becomes two dimensions because there are two parameters to take to get these data from these parts. But over here, you will not find two parameters. There is only one parameter, and that is a number. That's it. There is no rows, there is no columns, there is a number. So that is why it is known as zero-dimensional array. And if you print this, print array, so you will find only a number. Sorry, it's not been saved, and you will find only a number. See. So this is how zero-dimensional arrays are. Now, if we move forward to the one-dimensional array, so let's go for the second part, one-dimensional array. So in the one-dimensional array, what we're going to do, we're going to just write this particular dimension, what we mentioned. We'll just write this particular dimension. Array, let me comment this. Array equals to np.array, and inside the curly inside these parentheses, we will just pass on this square bracket, and we'll write the numbers 1, 2, 3, 4, 5, 6. So this is what a single dimensional array is. Only one row and multiple columns. I repeat, in the single dimensional array, there will be only one row and multiple columns. So this is what a single dimensional array is. And we will just go to execute this code now. Just let it get saved. Yeah, and we'll execute this. Okay. We haven't printed it, so we'll just print it. Print array. And we'll execute this. So you will find that the data output is something like this. So this is what the data output is. It's in one-dimensional format. Now, if you go for a two-dimensional array, then I will show you. Basically, we focus on the two-dimensional arrays because most of the data is coming in the two-dimensional arrays format only. But if you are going for the field of image processing and further other fields like on the process of image processing, basically what we have three-dimensional, four-dimensional, five-dimensional arrays. So at that time, handling the data is very difficult, and for that reason only we have the concept of data science. Now let us go for the two-dimensional arrays. np.array, and inside this we're going to pass on two dimensions. Now, to pass on the two dimensions, you need to be very careful that there should be a common list created, common square bracket for the two-dimensional arrays. Okay, so for that you need to first create a common square bracket, and then inside that square bracket you need to two square brackets where you will have the numbers 1, 2, 3, 4, 5, and then a comma outside the first square bracket, and then again a square bracket, and you will have 6, 7, 8, 9, 10. So you can see over here we have a square bracket that is common. This purple color square bracket, you can see it's common, and then sky blue colors are the internal brackets of the list. One is over here, one is over here, and combinedly it will create an array. So let us execute this code, then we'll find out. Okay, let me comment this and print this. Print array, and over here we'll just comment this part and we'll just execute this code. So you will find the data is coming something like this. It's coming in an array format. You can see it's totally in an array format, and this is not possible in list. If you do the same thing in a list, then what will happen? Just let me tell you. If you're creating a list and you're just copying this entire path into a list, control copy, control paste. The application will be same. The accessing the each and every component will be same, but the orientation of the data and the usage of the data will be different. If you're printing L, then you will find the data in almost same format, but the thing is, the processing is totally different than a NumPy and a list. See, this is a list. Over here, you will find out the list. And this is the orientation of NumPy. So you can see how differently they are oriented. So the processing of the data is also different in both the cases. Now you got to know the two-dimensional array. If you are clear with this two-dimensional array concept, just let me know in the comment section so that we can move to the three-dimensional array. If you understand this two-dimensional array, then only will be able to understand the three-dimensional array. Clear. Very good. So now what we're going to do, we're going to go for the three-dimensional arrays. Now we'll have the same thing, array equals to np dot array, and inside this function we're going to pass, we have three dimensions. So first of all, we need to pass a common bracket. This bracket will be common for everyone, and then we're going to pass the first dimension, the first dimension, first 2D and then the second 2D. So for the first dimension, we're going to pass on the square bracket, and inside this, we're going to pass on the elements of this 1, 2, 3, 4, 5, 6. 6. Okay. Now, then a comma, and then again an element of this, maybe 7, 8, 9, 10, 11, 12. Okay. So see, you can see over here, we have three braces over here. First is the common brace, that is the purple brace. Second is the brace of the first first dimension of the array. So inside this we have a two-dimensional array. Similarly, we will have a comma in the after the sky blue one, and then we'll cross on the second dimension of the three-dimensional array. Okay. Now in this, inside this, we'll pass on the elements like 13, 14, 15, 16, 17, 18, maybe 17 till 17, then a comma, and then again 18, 19, 20, 21, 22. So if you just print this statement, you will find out a very interesting fact that print, because this three-dimensional concept is totally new for everyone, I believe, because this is not covered in any of the C++ and other concepts. See, this is the how the data is being oriented. You can see this is the first dimension and this is the second dimension. You can see the axis over here. How many axes do you have? This is the rows, first row, second row, and this is the columns, first column, second column, third column, fourth column, fifth column. Similarly, this is the columns, and this is the z index or the z axis, you can say. So if you want to judge it as x by z, you can do it that this counts are the z axis, this is main counts, and inside this there are x and y axis. Y is the row and x is the row and y is the columns. So if you're gonna orient it, proper orientation of this, it will look something like this. Let me orient it over here so that it is clear to you how it will actually look, because it is a little confusing for you to see over here. So it will look something like this: 1, 2, 3, 4, 5, 6. This is one dimension, and then similarly 7, 8, 9, 10, 2, 11, and then a 12. And then again with a space, we'll have the next dimensional array, that is 13, 14, 15, 16, 17, 18, still 17, I believe. Yeah. And then again, we have over here 18, 19, 20, 21, 22. So this is how the orientation is. It will look something like this. We have these data. And now when we go for the indexing method, we will be knowing how to get the values of this. Now we have another property of this NumPy, and that is to check the dimensional of the array. That at what dimension it is coming actually. So to check the dimension of the array, for example, we want to check this dimension of the array. For example, if you want to copy this and print it over here, and if you want to comment this, and we're going to just print, and the method of checking the dimension is the name of the variable, array variable dot ndim, that is number of dimensions. This is what ndim is, and then we'll just print this. So let us execute this code and let us know. So we'll just execute it, and we'll find that we are getting it's a two-dimensional, but it should be giving us a three-dimensional. There is some mistake. Let us put another component over here. It's giving some raw data. I believe it's a compiler issue because it should have given you the three-dimensional array. There may be some compiler issue over here in VS Code, the mean_w compiler. So mean_gw compiler may have some issues over here because it should have given you the three-dimensional arrays. So we will just check it out and we'll just let you know with this. But you just remember this, that ndim gives you the dimension of the arrays, whichever dimension it is. Now, if you go to the next part, then you will find we will have the how to access the elements. We need to know how to access the elements. For example, if you want this one over here, how to access this. So for that, we're gonna just go a little, and this is known as the indexing of arrays. So we're gonna go with the indexing of arrays right now. Yeah, we have got with the indexing of arrays, and now we'll access the arrays. So first of all, we'll start with a one-dimensional array. So first of all, we'll just go with the array equals to np.array, and inside that we'll just pass on the one-dimensional matrix. Okay, so this is done. And now what we're going to do, we're going to just access the elements. So if you want to access the fourth element over here, that is the position, if you count 0, 1, 2, 3, then you will just access it like a list. Print a of 3, array of 3. That's it. If you're going to do this, if you're going to print this, you will find the element over here that is 4. Okay, so this is how we have one-dimensional array, access of one-dimensional array. Okay, so similarly we'll go for the two-dimensional array. Sorry, not indexing, it's accessing. Okay, so over here array equals to, if you're gonna copy this part and comment this entire part and print it right over here. So to make it a two-dimensional array, we'll just require another dimension. So this is what we require, and then we'll just go for this another square bracket at the hole, because we want it inside a particular list. So this is done. Okay. Now what we're gonna do, we're gonna just print. Now for two-dimensional array, we will just have the variable name, and then in the indexing part, we will take the position. This number is the 0th position, the row value actually, I comma j. So let me copy this. Let me show you what I meant to say. Okay, so we are done. So you can see over here, it should be fine. Okay, so you can see over here we have got this type of array. It's a two-dimensional array, and inside this, what we're gonna do, we're gonna just take the row and the column values. Now these are the row values. So it has two rows, 0th row and first row, as per this data. So if I want to take this element, the third element, so it has 1 comma 2 as per the position. This is 0th, this is first position, and this is in the column 1 0 1 2. So it's 1 comma 2. So I'm gonna write it something like this, 1 comma 2. And if I write this, then directly it will give you the data 3. Now if you want to change this, for example, if you want to make this 6 so that it is seen that it is exactly giving you the correct data. So now if you execute, it will give you 6. So this is what the two-dimensional array execution is done like. So did you understand? Just let me know in the comments. Yes, very good. So if you want to sum it, means add the numbers in an array, it's almost a similar way how we did it for the list. Now we'll just copy this element right over here, and we'll paste it over here so that we get the two-dimensional array. And if you want to print the numbers, for example, if you're going to add the first element to the first element of the second number, so how you're going to do this, you're going to just go like print, then you're going to just put the array first 0th row and 0th column plus array of first row 0th column. So 1 plus 1 will be 2. So let us see if it gives the output as 2. It's not been saved. It's giving you the output as 2. You can see. So 1 plus 1 is equals to 2. Similarly, if you make it to first position, and this is also the first position, then 2 plus 2 equals to 4. So the output should be 4. So you can see the output is 4. So this is how the things goes over here. If you wanna do the for loops and all, then everything is the same. You're gonna do the elements. You're gonna take two loops, I loop and j loop, and you're gonna add it according to your concept. So this is what the concept of over here, and the array concept is like this. Now, if you wanna go for the 3D arrays, three-dimensional arrays, then you can do the same thing. You're gonna copy a three-dimensional array. For example, if I'm copying this arrow right over here. Okay, so this is done. And now what we're going to do, we're going to access the data. So we'll just print the variable name. So let me remove this first. And in the indexing, what we're going to write three values. As I told you over here, it has three values over here. The first value denotes as which dimension it is, either this dimension or this dimension, which dimension it belongs to. The second value is the row position, and the third value is the column position. So did you understood this? So if you want to access this value, for example, this 19. So this 19 comes, if you see over here, this 19 comes in the second dimension of the three-dimensional array, and inside this it comes with the second row, and the column number is second column. So we will go for first 1 comma 1 comma 1. So this is what we have to go for, 1 comma 1 comma 1. Now let us go for this 1 comma 1 comma 1. And if we go for this, if we execute this code, let us give it time to get saved. And we'll just execute this code. It throws an error. Too many indices for array. Okay. I believe we made some mistake. Let us recheck it once. If we made certain mistake, this is correct. This is correct. And if we go for here, this is also correct. Maybe it is not the same. We have 5 over here. We have 5 characters over here. We have 5 over here, and we have 5 over here. Let's see now once it's showing. So the issue was that we haven't used a square matrix, and that was the only issue. That's why it's not showing us the dimension. So I believe it was the issue over here also. So let us check once the dimension also. We haven't seen that the numbers are different. We are using the square matrices. Now let us check this also once. Yes, we are getting three dimension. You can see. So this was only the issue over here. We found it right when we were testing it. So this was the only issue, that we need a square matrix. We cannot have a matrix over here like one is having 15 elements and one is having 10 elements. This is not considered. So it will give you the error data. So you're gonna have a proper matrix format. Now over here we got the data. If you wanna have this 10, so it comes in the zeroth dimension position, and first row, and the column is third column as per the position. Third position it is 0, 1, 2, 3. So let us execute this code now, and you will find we are getting this 10 right over here. Let me comment this. Okay. So if we execute this again, we'll only get the 10. Okay. So this is how this dimension of this works. Now you have the means opportunity to have the negative indices also. Now how to use the negative index? You wanna just comment this. negative index. Now to use this negative index, we're gonna have this array first. NP dot array, and inside this will pass on a function, and inside this function we're going to write the name of the arrays like 1, 2, 3, 4, 5, and then again maybe 1, 2, 3, not 1, 2, 12, 13, 14, 15, 16. Is there 5 elements? Yeah, it's just 5. And then we'll just have a common braces for these elements, and that's it. So this is done. Now we'll just go for this negative part. So we'll just print. Now if you want something like this element, if you want 16, so rather going for the from the starting 1, 2, 3, 4, 5, the fifth element, that is the fourth position, rather going for this, we'll just go for the reverse. And how to go for the reverse? The variable name, and then the row position 1 comma -1, and -1 indicates from the reverse counting, that is the 16. So let us check it out, and it's giving us 16. If you provide -2, then it will give you the other numbers. Let us execute this. 15. Similarly, it goes over here. So did you understood till here? Just let me know in the comment section. Yes, very good. So now we will go with the how are you counting rows? Okay, see this this matrix, what we can have over here. This is a matrix, and it has this type of numbers. It is something arranged in this format. Or else I can show you by printing this. It will be better. I will just print this so that it's easy for you to understand. So let's execute this. See, this is the entire matrix. You can see over here. Now over here, what we have, this is the first row, this one, and this is the second row, this one. So the position of the rows are 0th position and first position. So we want the element to be a first position row. So we have written 1 over here. Right over here, we have written 1. Now, if you, what we want the position of 15. So 15 is somewhere over here. So if we want a negative count, then it is having -1, -2. So -2 is the count because we are counting in a negative way. So -2, and we will get 15. Did you understood? Okay. So now we'll move for the next topic, and that is slicing. Now slicing is a bit difficult, or it's not a difficult one, but a little bit not that easy to understand like list. It has a little complicacy, but it is easy, not that tough also. It is easy. So slicing. So today I will not go with the brief of slicing. I'm just telling you what is slicing is, as you all know what slicing is. So over here in NumPy, slicing has two methods. Slicing has few uh, ways of over here. So there are some steps. Number one, you can say that this is one format of slicing: start position, colon, end position. So this is one format of slicing. Then second format of slicing is start position, colon, end position, colon, step. Step means how after how many counts you're gonna have the number. For example, you have a number from 1 to 10, and you wanna slice it from first 1 to 9. Now from 1 to 9 it will give you the data, but if you are giving step 2, that means it will print 1, then it will print 3, then it will print 5, and then it will print 7, and then it will print 9. Now 9 will be excluded because if you are printing from 1 to 9, that means it will always have 9 minus 1. Okay, so I hope you understood this. Now the third thing is, if you start the number from, if you give something like this, like colon and then the end position, like 9 colon and then the end. So this will start from 0, 0th position, starts from by default from 0th position. Okay, now similarly if we go for this, like we have something like start and then a colon and we write nothing, that means it will iterate, it will give you data till end position, until the end. It will give you data till end position. Okay, now in this we have several dimensions also. We have slicing for several dimensional arrays. So we will not discuss this over here now today, because already we have completed a lot of topics and a lot of things we covered. Like we have covered today what is NumPy, why is it important than a list, and how it is useful, the version check, and one-dimensional, two-dimensional, three-dimensional arrays, finding the dimensions and checking the dimensions of the array, then indexing, how to index an array of 3 different dimensions. So many things we have done today. So we won't move forward with the slicing. We'll cover the slicing in tomorrow's class. So are you having any doubt? Just let me know in the comment section. If you don't have it, then we'll wind up the session. No doubt. Okay, guys. So thank you for being with Teckat. So we'll just meet you in tomorrow's session. Thank you. And tomorrow, I believe it's Thursday or Friday. Tomorrow is Friday. So I want your task to be done. So just let me know, did you complete your task? Just let me know. I believe you have not completed till now. You are almost doing it. So I want your task tomorrow to be done so that we can just work on the doubts that you are having while going for the task. Okay. Tomorrow we'll go for 15 to 20 minutes on the topic, and then we'll discuss the previous task, whatever we had made. We'll just finalize that task, and you will be getting a new task for this Saturdays and Sundays. So so let us meet tomorrow then. I'm just winding up the session. Thank you guys.